Hi, this is Calandra. In this video, we'll go over how to determine the domain of a function from its equation. You'll only be asked to find the domain of a function from its equation. The range you'll only have to be able to determine if you're given the graph of the function. The domain of a function is the set of all x values that do not make the function undefined. Below is how we can find the domain of various types of functions. Well, for a polynomial function, where quadratic is an example of a polynomial function, you may have x to the fourth, all of the coefficients are real numbers, and your variables have positive exponents that are integers. The domain of any of those types of functions will be all real numbers. So these are the nice functions. You can put any x value into them and they will not make your function undefined. Well, for a rational function, and remember that's a polynomial divided by another polynomial, the domain will be all values that do not make the denominator equal 0. So all values that do not make the denominator equal 0. Okay, for root functions with an even index, like a square root, you're going to set the radicand, which is the part under the radical, greater than or equal to 0, and solve that inequality. The answer that you get will be your domain. For root functions with an odd index, like the cube root or the fifth root, the domain is going to be the same as the domain of the radicand. Okay, so in summary with these radicals, if you have an even index like a square root, you can only find the square roots of positive numbers. So that's why you set the part under the square root greater than or equal to 0 and solve it to get your domain. If you have something like the cube root, you can find the cube root of a negative number. So that's why whatever the domain of the part under the radical is going to be the domain of that function. It does not have to be positive. So let's use these rules to figure out the domains of the following functions. Write your answers in interval notation. Okay, for part A, this function is a polynomial. So when finding the domain, we like to see polynomials because that has an easy domain. It's going to be from negative infinity to positive infinity. Any number you can think of, you can plug in for x, and it's going to give us an answer for y. Okay, moving on to part B. Okay, we have a square root function. So this square root will be defined as long as whatever is under the radical, called the radicand, is positive. If it's not positive, that means we're going to have imaginary numbers. Okay, so when finding the domain, we just set the radicand greater than or equal to 0, and now we need to solve this inequality. So we get that 2x is greater than or equal to 1. Divide both sides by 2, and we get that x is greater than or equal to 1/2. So to write our answer in interval notation, 1/2 is the smallest value in this set. Since we have an equals with it, we do a bracket. And then x can be anything greater than 1/2 as well. So comma infinity. So what this means is if I pick any number in this interval, 1/2 or bigger, and plug it in for x, I'm going to end up with a positive number under the square root, which means it's in the domain of that function. Okay, going on to part C, and let me just write that we're dealing with a square root function here. So square root has an index of 2, So this is our even index. Okay, part C, we're dealing with a rational function. So whenever you see a fraction, we know fractions will give us a problem if we have 0 in the denominator. So we can put any value in for x except values that make the denominator equal 0. So we know that x minus 2 cannot equal 0. And we're going to solve that just like an equality. Add 2 to both sides, and we see that x cannot equal 2. So if we can have anything except for 2, the way we would write that interval would be from negative infinity until we get to 2. Since we want to leave 2 out, we make a parenthesis with it, union, and then anything bigger than 2. So again, a parenthesis, 2, comma, infinity.